Hello, my name is Toney, and this is my entry for the ENCMP 100 programming contest. My project is the game Dots and Boxes and a program to play the game against you. First, I'll cover the rules of Dots and Boxes. Dots and Boxes is played on a 4x4 grid of dots. Players take turns drawing lines between adjacent dots. The goal of the game is to create boxes. A box is owned by the player who completes the last line of the box. It does not matter who drew the other lines around the box. Only the one that completes the box matters. If you use your turn to finish a box, you must take another turn. When all of the possible lines have been placed, the player who owns the most boxes wins the game. The AI is split into two major processes. During the first half of the game, where both players don't have to draw the third line in a box, the computer attempts to set up a particular board state that gives it an advantage. In the second half of the game, chains of boxes form. These chains can be filled in completely by a single player on consecutive turns. The AI attempts to create a board state that has one chain that is much longer than the others and runs through the center of the board. As both players attempt to give the other as few points as possible, when the AI takes the last move, it should be on the longest chain, giving the AI enough points to win the game. The AI is assisted in creating this board state and allowed to make the last move by starting second. Above all else, the AI will always draw the last line on a box with 3 sides completed. The code for the AI is split into 4 functions in order of priority. Each function attempts to make a move, and if it cannot, the next function tries to make a move. The last function, chains, is guaranteed to make a move. The first function, complete, finishes the 4th line of any open box to score points. It is important that this function is first so the AI does not miss any opportunities to score points. The next function, spoke, counters the opponent's attempts to create a long chain that does not run through the center. This is the most important function in setting up the board state. The third function, corner center side, puts all possible board moves into a priority list. The AI will make the first legal move on this list that does not allow the human player to score in the next turn. The order of the moves on the list are important in setting up the desired board state. The last function, chains, creates a 2-dimensional array that shows the positions and lengths of all the chains on the board. Chains will then pick the shortest chain and make a move in it, giving the opposing player the smallest amount of points possible. Another interesting area of the code is the array I used to record which lines were filled in. In the lines placed array, 1 represents a drawn line, and 0 represents a line that is not drawn. The challenge with this array comes from how there are 3 horizontal lines in some rows, and 4 vertical lines in others. This staggered the array, leaving spaces unused. Instead of making 2 arrays, one for vertical lines and another for horizontal lines, I decided to keep the designs shown. The underlined spaces in the lines placed array show reference points for finding lines relative to boxes. Each underlined space, along with the space above it, below it, and to the right of it, form the boundaries of a box, allowing the computer to determine where any line is and if any box is bounded more easily. Before starting this project, I knew that I wanted to create a program to play a game. Once I decided on dots and boxes, I started by making the game playable by 2 human players. Once the game mechanics were set up, I then created the AI, starting with the simpler functions of the first half of the strategy and finishing with the chains function. After fixing the bugs, I went back to prevent the human player from making illegal or dead-end moves and added some of the text and intro screen. I hope you enjoyed the presentation. I have beat the AI. Can you?